We have quite a quorum. So depending on where you are, good morning, good afternoon, good evening to all of you. A warm welcome to the Q2 Roundtable discussion on data management. My name is Deven Dhulia. I represent data strategy professionals and will be moderating today's discussion. So data management, as specified by Dharma International, covers a wide set of knowledge areas in the data space, ranging from data management to data governance, data architecture to data modeling, from data warehousing and big data to data security and data storage and operations. For today's roundtable, we have an exciting panel of experts who will participate in a lively, interactive Q&A session on three relevant topics: data storage and operations, data security and privacy, and data modeling. Before I ask them to introduce themselves, here's a quick recap of the format of this roundtable. I will ask each panelist several questions on the above topics from a predetermined set, and they will offer their insights based on their areas of expertise. I'm going to hand it over to the panelists to introduce themselves. Karen, would you like to go first?
Hi, thank you for choosing me first. I'm Karen Lopez. I'm data check everywhere on the socials except for Twitter. I consider myself a data evangelist. So that just means I was born this way to be a data person.
Great, excellent. Mark, would you like to go next?
Yeah, thank you for having me. I greatly appreciate it. Mark Freeman, I lead go-to-market over at Gatewell.ai. My background is a data science turned data engineer. I joined Gatewell as the first employee because this problem between data producers and data consumers not really talking well to each other. I dealt with that throughout my career in startups. I was like, let me try to solve that and focus on a company to do that. And then through that work, I'm the co-author of the upcoming O'Reilly book on data contracts.
Data contracts,
Cool.
excellent. Yeah. We have a nice juicy question for you on that later in the series.
Love to answer juicy questions.
And finally, Lauris, would you like to go?
Hi, my name is Lauris. I'm a consultant for Saltworks, and I specialize in data governance, data platform, and data privacy, mostly how they play together. I'm very excited to be here. My background is really in engineering. I have more been burned by the fact that engineering projects fail when the governance is not there. And I was like, hey, you know what? I start to get that. And so I really got into governance from the failures in engineering. Governance helps people be successful. And that's what I'm here to preach.
Any which way you can finally get to governance is a good way. Just a quick recap of the topics that we have for today. We begin with data modeling, which helps design the database. You build your logical models in your physical data models. And then data operations helps to build the database and execute the DDLs to create the physical tables, schemas, indexes, views, etc. Data storage populates the database and loads the data with the data records. Data security ensures that data at rest and data in motion is secure and not subject to vulnerabilities and threats. And finally, data privacy ensures that sensitive data is protected. The confidentiality remains intact while managed by the data custodians. The underlying theme of our questions today will be how best to ensure that we design, create, and load databases and access data to maximize their security and privacy. We will cover topics such as cloud database operations, data privacy by design, data modeling methodologies, and vulnerabilities introduced which might violate the security and privacy of data with the advent of agentic AI. First, a general question for everyone. How will agentic AI change the role and responsibilities of an organization's data teams in the coming years? Mark, would you like to go first?
Yeah, this has been very pertinent. I actually was at an industry event yesterday talking to a whole bunch of people who are implementing AI and how it changed things. The biggest change that it does is that overnight eroded all the work around processes and training around security. People are incentivized not to use those. I found really interesting. I was talking to a potential customer last year and they were like, yeah, we did research on how many AI tools are being used by our company. They thought maybe like 10. There were 100. And they were just like, how do we keep track of this? There's so much shadow AI or tools available. And also people are incentivized because the gains you have in productivity, especially as a non-technical person with these tools, you're going to break the rules to get things done. It's kind of the best practices we've had on its head. I can't speak on the European side because they take security way more seriously than in the US, but people are okay with that erosion, which is not okay. People are accepting that initially, but I think in the next year or two, they're going to have a rude awakening, which is going to highlight the importance of governance again. Governance is going to look much different because the rules and the immutable truths have changed completely with AI. That's a high level. I'm happy to go into more detail for other things, but that's my take.
So, Lauris, what do you think about the data teams as a result of this erosion of responsibilities and sidelining of data governance? Do the roles of a data engineer and a data steward change with agentic AI?
They will. The erosion is also creating the opportunity. A lot of time when you have a data team, it's a very fundamental question of skills that are concentrated in one part of the enterprise. With the LLM, all these tools enable people to do it. And the skill gate that this team had is gone. But as Mark was just saying, the security tab that have been opened are completely different. Where the security goes is LLMs are fundamentally not making any difference between content and code. Every company had a very good code governance, which is like you would not go into production and type anything you would see. Fundamentally, your email has become content that can contain information. If someone sends you instructions, someone could send you code via email and suddenly all your production would execute it. Companies are not ready for this. We're just waiting for the next massive problem to happen. The roles for data team is going to shift from being the gatekeeper or skills to become enablers for the enterprise. The security of the data is going to become paramount because now if data equals code, all your data needs to be secure.
True. They probably become more like agentic orchestrators rather than running reports and dashboards, probably designing the right prompts for these agentic AI's applications. Karen, what were your thoughts on this?
So I wanted to start this as every sort of data modeler would, is I want to get to the wording of the question because I see this question has two fundamentally different parts. One is how are our data programs going to update to help support the uses and deployment of AI things? But the other, and my favorite, what I'm focusing on is how are we going to leverage AI to help us be better data governors, better data management people, faster. So I'm most looking forward to how we can use this, which still has security issues because now our data models, our data structures, our data code becomes at risk. But I'm still looking forward to this because one of my sayings is the best data modeler is a lazy data modeler because we want to focus on the hard part, not the easy tasks that could be sent off to an agent or a bot.
So you're seeing divided responsibilities between the agent as well as the data teams?
I'm saying that whenever someone asks me about AI and data governance or data management, I realize there are two questions embedded in that. How would we use it? And also, how do we support the teams that are deploying AI or using AI? And how we're going to get the data prepared for them? Those are two separate questions, but both important.
Great. Thank you so much. In your experience, what are the most common modeling mistakes that create long-term technical debt? This is right up your alley, Karen, so please go ahead.
Yeah. So my go-to answer for this is always thinking that data modeling is only about designing greenfield databases, like from scratch, bespoke databases. And it's much more than that because typically we took a course that was focused on that. Even your introduction, we're focusing today on the more technical levels of the Zachman framework instead of the upper ones. That's one of the biggest mistakes because now people aren't doing as much data modeling because we aren't designing as many databases from scratch. It's important to understand data and to take the time to write down our understandings of it. And the data model is the best and probably the only real way of documenting what we understand about data and how processes impact it.
So what modeling mistakes do you see coming in today's data modeling, which might create long-term debt when you're formally doing data modeling?
Yeah. One of my mantras is the development and deployment world has been taught that nulls are absolutely evil, should never be tolerated, and we need to provide a default value for them. I call this faux nulls. That's great for text fields, but in numeric and dates and times, those columns in your database have constraints. They have to be a valid time. And that's how we end up with a bunch of users in our system or customers in our system that we think are 150 years old. It's because someone provided a faux null because we didn't know the data. Therefore, all of our aggregations, all of our code, all of our analyses, they're all skewed in a horrible way that we know about and we tolerate.
Yeah. And then we end up doing a lot of data cleansing in the post-application processes. Lauris, what are your thoughts on this?
Timestamps are really the devil, especially if they are not UTCs. Or if they don't contain any time zone information. If you're a multi-country operation, that's a very big classic that is extremely hard to pay off. At a higher level, I see it is if you have many engineers in the room, they will go for a modeling to use a specific technology. So they will use graph database, for example. They will use some very, very complicated modeling sometimes. Getting the right understanding what the data is, what process it models, and using the right thing from the beginning without making it too complicated is a very hard balance, and something that sometimes people are mistaking the means for the ends and should be a bit wary of.
Sure. Just jumping straight into building a physical model for specific application, rather than taking the time to build a logical model, which clarifies a lot of these business rules. And that's all embedded in your DDLs. Then that becomes a problem later to decipher what's going on, missing effective dates, etc. Mark, any thoughts?
Yeah, my take is going to be more towards on processes aspect of it. There's too much emphasis on the best practices and what's the best approach. What I'm trying to get at is the reality of how these things are implemented in the business. I can't speak to enterprises because I've mainly been in startups my main career, but for startups, it is never a data person who implements the first database. It is always software engineers who are spinning things up quickly. There's roughly 4 years technical debt built up before the first data hire is even brought in. And so if you go in thinking you do best practices from that starting point, you're going to be in a world of pain. You really need to think, all right, what is the crawl, walk, run of this?
That's true. Yeah, you're right. The data is always an afterthought. Hiring the data team always comes after the platform engineering. Enterprise data models present a holistic view of cross-functional enterprise data across various business domains. In a multi-cloud enterprise landscape with proprietary application models, say if you have a Salesforce and an SAP and Workday, etc., and a canonical model for data exchange, what is the value add of EDM still? Are they still important? Are they still of value? Karen, would you like to go?
Yeah. So you use the word multi-cloud, but you mentioned some software as a service thing. Multi-cloud really doesn't impact enterprise data models because that's more of a location and an architecture. I have always started with enterprise data models, especially the logical ones, for my canonical models. I pull from those things. I see the data model entities and attributes and some of their physical constraints that we might put on them as something I want to bring into my canonical models. The vast majority of the data models I've worked on recently have been those the exchange data models, in order to separate to the source and the sink so that we're not overly designing for a specific technical product. So for me, that's the point of an enterprise data model. But we never really did it the way it was trained. We were trained to take 2 years, go off and build an enterprise data model, and then you can start using models. I know a lot of training did it that way, but I don't think that's truly reasonable. You just start taking an enterprise data approach when you're building your first customer model, when you're building your first product model, those sorts of things.
That's an excellent perspective. You don't have to boil the ocean, but even if you're doing domain by domain, have that enterprise view for conforming your dimensions and so on. Any thoughts on that, Lauris?
I don't have much to add. I really like Karen's answer, and the don't boil the ocean.
Yeah.
I do feel, though, for the crowd, when you have the enterprise data model, it happens at a very strategic level. And so you're putting yourself at a very high level. And then the CDMs are where the action is happening. Maybe something to say about this is the EDM, you think it needs to spend a lot of time on it and it's perfect. But what Karen describes, it's also that it changes and you need to make it evolve. It will evolve slower than the rest. It will change to adjust to what your company is doing, and focusing on the core of one place and then expanding this model to satellites around it to gain the complexity only as it makes sense and brings value to the company is a great way of doing it.
And it also brings into focus the enterprise canonical model, as Karen said, which is rather than having point-to-point integrations, building that canonical model so that the data can be exchanged in an integrated way is very important as well. Mark, any thoughts from a software engineering perspective?
I don't have much to add on that, mainly because I've been in startups. So I can pontificate about the enterprise, right? But I don't think I'll be the right person to speak to the nuances and challenges of that. I've seen some cases from customers I've spoken to, but I think Karen and Lauris answered that perfectly.
Excellent. Okay. What strategies have you found most effective for managing cost and performance trade-offs in the cloud storage platforms? What are the trade-offs you have between cost and performance? What are some of the effective strategies that you would be using? We're looking for architecting for access patterns, automating governance, things to make this more cost effective. You trade off between performance and block storage. You have high cost file storage, but you have great performance. For low commodity storage, your performance can be a little less. How do you manage those trade-offs?
I think the performance of the system is rarely an issue. Performance of the cloud and performance of system is high for most use case. A system like Kafka, maybe 10 years ago, used to be like something that everyone needed and was hard to run, hard to get very performant. And now you have systems like WarpStream, for example, that enables you to have everything that Kafka offer, but actually it runs on top of S3. So it runs on top of blob storage. Because the real thing with performance, it's a bit hard to decide because everything works. It's really hard. There's a number of use cases when you see performance being an issue. It's rare. It happens. Don't get me wrong. It happens. And sometimes you do need to bring in the specialist. But actually, most company performance is really rarely the issue. If you compare it to modeling, for example, I will recommend one strategy, and I'm going to put my privacy hat on. It's what my colleague Marcus wrote a great article about. It's called data holding versus data offboarding. There is a great way to get performance cost, performance improvement, cost improvement every single time. It's getting rid of data, being super deliberate about removing data early. You don't need it, and being very deliberate about keeping the minimal amount of data actually improves your cost, improves your security profile, improves your risk profiles, improves the performance of the tables. That works at every single time and on every single system. Do you do it just for performance? Not really. You do it because it brings a huge bucket of advantages.
Excellent. That's a great perspective. Also during the data life cycle, as you go from OLTP systems, which require like this high cost data storage, to OLAP, which requires like longer running queries, performance is not that critical. It's not going to stop your bread business. So that can become more cost effective on low commodity servers, etc.
I just want to add something. Even in the border between OLAP system and OLTP system can even blur very slightly. There's a new format like Iceberg and Delta Lake. They enable you for very simple use case, simple application to just use your OLAP system as an OLTP backend to serve queries on top of them. And the performance, the cost is a bit higher than doing it the right way, but the commodity cost and what you save in people time is worth it. We live in a very exciting world with it's much harder to say there is a wrong answer here. And it's much more, hey, what do you feel comfortable doing? What saves you time? What gets you faster and closer to your goal?
Yeah. The lakehouse architecture has changed everything, where you have a single platform to do all of your use cases. Depending on what kind of use cases that you have or query loads, you commoditize storage that way. How should data engineering teams adapt as responsibilities blur between data product owners, platform engineers, and analytic teams? So earlier it was like these discrete with platform engineers building the platforms, and then the data engineers come at the end to build the ETL and the ELT processes. Product owners were essentially releasing the packaging and releasing product. Now these responsibilities are blurring. How should data engineering teams adapt to this new changing world?
I think something that's really the most fascinating thing to me is the role how AI changed the budget landscape within an organization. Before, for so long, you had software engineers like, hey, we're focused on our platform, focused on building features, data team building ML, doing the analytics. And then AI comes about where now it's just an API call. And now all the software engineers, the CIO, CTOs are fighting for this ML heavy thing that the data team was like, this is ours. And so that is one, I think, big drivers of this kind of, I've been calling it a collision course between software engineers and data teams. I would say there's two paths you can take to that. You can be confrontational, try to protect your budget, which I've seen some folks do. Like, hey, we're the data experts. We've been working at building ML and AI. We should be the ones to own it. But on the software side, they have a track record of we get into production and productize it. And I argue that this is the moment for data teams to finally get the buy-in of software engineers. These are all the data best practices that we've ignored for so long. We finally see the pain points you're talking about. They're finally seeing, oh, if I put an LLM in a chatbot and I give it bad data, it's not the model itself, it's the data itself. So maybe I should start caring about the data. Right now, there's more entry points to collaborate. I wrote an article around what I call the data conscious software engineer, where it is these kind of staff plus level engineers who have at least done one data project. Specifically at that staff level, they think as systems view. So if we're working with engineers who only work on one service, they're not going to see this data component. But once they start seeing how the services interconnect with each other and how the data and API calls go through each other, data becomes very important to them. And that's the person that you want to build inroads with to start getting that champion within the engineering org to start caring about these data practices. And so that's how I see, like, this is our time to finally be embedded within the org that has the most money for budgets.
That's a really well-constructed answer. And so you think that data engineers should also be like embedded in software engineering teams during design phase as well?
Embedded, that's definitely a little bit hard, but I think it's more specific to the company. If you have like more discrete units of teams, sometimes you have embedded groups. I think that's very dependent on the company. But with that said, the data perspective, especially like the modeling or the edge cases at design time. So I think they need to be embedded with the product manager to
Yeah.
get creating the use cases for the software engineers to implement.
Sure.
So I was around when relational databases were new, which was a big change to the data world. And then the next big change for me, from my point of view of a data pro, was the advent of data warehousing as opposed to just running reports off your transactional. And we learned a lot about our data quality, our technical debt, our missing data. Why are all of our weather stations reporting 0 for a year? Well, that's because a hurricane came through and blew away with all the stations. We don't believe in nulls, so we gave them all zeros. And now our weather forecasts are based on zeros. The reason I bring that up is I'm seeing the same thing happening with this advent of AI and LLMs. That is because data warehousing in the recent past was the group responsible for cleaning up that debt, dealing with it, aggregating it, documenting why it was missing. But yet AI models, we're not pointing them at data warehouses. We're going back to pointing them at the source. Well, we never fixed those problems that were in our source data that we fixed in our ETL or ELT processes. So we are learning the same lessons. The business is finding out our data is not in good shape. It's normally persistent transactional form. And we had all the same questions like, how does the advent of data warehousing change what data people do? Who's responsible for this? Who's responsible for data quality? How do we deal with performance issues? Who's responsible for that? And so I'm trying to keep looking back on the lessons we learned during the advent of analytical processing. And then we learned them again with self-serve BI because that was slightly different. We're learning them again slightly with Lakehouse, where we have both the highest granular data and highly summarized data. So I'm trying to learn from lessons in the past. I want to encourage people to talk to people who are around during these big changes to see what we learned about people, process, and tools.
That's an excellent point. Thank you. Next question. With the popularity of data mesh architecture with independent data domains managing discrete data products, does the importance of data contracts become more imperative? Lauris, would you like to go?
I'm going to attack the question a bit, but I'm going to put my ThoughtWorks hat, inventor of data mesh. If someone tries to sell you data mesh and doesn't tell you to do data contracts, they are not selling you data mesh. The data contract is a critical part of any form of data mesh and data product approach. If you don't really have it, a lot of things don't work. The contract has ownership recorded that has all the usage data, which kind of forms the basic for data product, and being both machine and human readable. That is the thing that powers automation, which has the center of federated computational governance. So if you don't have data contract, it is really hard to do data mesh.
So for the benefit of the audience and for us, could you explain what all goes into a data contract?
I think I can go into that one. I'm literally writing the book on it right now. I'm actually editing this chapter right now too. So there's basically 4 key components that goes into data contracts. And one thing I want to highlight is the difference between the data contract spec, which a lot of people focus on, versus the data contract architecture. For the data contract architecture and pattern, you have the data assets, which is the foundation. Like, what are you trying to protect? And then you have the detection. Can you detect the metadata across the various systems? And it's not just, hey, layer read this database. It's like metadata across like your code, your logs, everything you can think of. The more metadata you can get, the better your controls can be. The third part is the contract spec, where your expectations around that in a machine readable way, typically use YAML. The contract spec, there are standards popping up, but the industry doesn't have leaned into one yet. But basically for the spec, can you say which asset it is? Can you put a key around it to make sure that it's version controlled? Can you put the expectations for that at a minimum? Finally, how you operationalize that is through the CI/CD process. When changes happen, can you read the metadata based on the change impacting it? Can you infer if there is a data asset that this change will impact? And then from that change, can you ensure that it is under contract and is meeting those expectations? One key thing with that is around prevention compared to observability, which a lot of people conflate with contracts. Observe means that it's already happened, right? And so you create this feedback loop where you observe what's happening to the data, therefore informs you what rules you need to have for prevention. And then more edge cases pop up along those lines. Going back to what Laura says, data mesh is like creating those domains, specific domain knowledge that will go into the contract spec itself to enforce and operationalize that. That's at a high level. Happy to go into more detail about other things.
That's a great summary and explanation of the architecture and the feedback loop. Do you see tangible benefits to the data mesh architecture in places and organizations which have formal data contracts in place?
Yeah, I wasn't skeptical of data mesh, but it's more so one of those things that remind me of the big data push where everyone's talking about big data, but who is actually doing it? From being on the vendor side, I talked to all these different enterprises. Every enterprise is pursuing data mesh, pretty much close, or they have a strategy or initiative. And I think the big challenge with data mesh, and I think Lauris can probably way more better than me on this, is that do you have the strategic buy-in at the executive level? And that's so hard to do. But I think for enterprise, they're thinking about 5-10 year plan makes sense. And once they have that buy-in, I'm seeing data mesh really take hold. More importantly, I think Zermatt, when she had those initial articles, forced people to rethink what is important for data, what is worth modeling, and who owns that knowledge. And so I think the data mesh is more of a huge cultural shift. And Zermatt looking forward of what will data look like in the next 5-10 years and what needs to exist for that.
One of my concerns with data mesh is not actually about data mesh, it's about people. I'm afraid that the spreading of governance across business units and everything sounds good. And I'm terrified of the cultures in organizations that are going to adopt this just for anarchy purposes and not for having democracies everywhere. We went through that same lesson when Agile came out. Agile has been used both as a great change to the software engineering process, but also as a horrible excuse for avoiding decent practice. That's my big fear. So I believe that while we are adopting data mesh approaches, which puts the data there, is that we still have to ensure that we are protecting the data, classifying the data, ensuring its integrity. My big fear is that when a new way of doing things, we learned that with data warehousing too. We'll just make really wide tables and put all the data in one table and let people point queries at it. That didn't work out well either. Some organizations are going to go down that path. They're going to get burnt and they're going to learn those lessons. And then they'll come back to figuring out how data mesh works so it gets the best cost, benefit, and risk outcomes.
Federated data governance becomes key in this kind of environment, as well as a unified catalog, like the Unity catalog, to bring in all the metadata for each of these. Sorry, go ahead, Lauris.
What we see in our customers is exactly what Karen was mentioning. Main reasons for failing are cultural issues.
Yeah.
And because usually people started too big, and so companies started to have these huge transformation programs that didn't work out. What we see now is more people are taking it in bite size, and they start with data products. So they start at thinking about how to organize teams and their data by putting the people consuming the data and the people producing the data together to talk more regularly. From there, starts to have the governance. They start with this type of transformation of having data products, having governance centered around data products, and try to split the role of responsibilities, because central data teams or central governance team can sometimes be like, okay, I have this thing broke and I have no clue why or what has happened. And this is the problems that make them come to, okay, we're going to start to change and start to push down the responsibility. Once they have done that, they rush to the next set of problems around governance. And okay, so now we need to build in the federated compute governance, and they realize they need to do the automations and so on and so forth. So I think it's really a journey. Companies are anywhere from having very close to data mesh, if they were really good at Agile, really good at microservices, really ahead in automations. And if you were a bit more, you start with data product and you constantly build on top of it. So data mesh is something in the future for many companies.
You hit the nail on the head about having the data producers and consumers be part of that team, because customer, for example, is not just within the domain of sales and marketing. It's consumed by finance and consumed by legal. Which data domain owns customer as a data product, right? It has to be this federated team of all of these domains, like representation of them, to be able to do justice to the data mesh architecture. As organizations adopt multi-region and multi-cloud architectures, how should data teams approach data locality, latency, and regulatory constraints in storage design decisions? Global footprints in the enterprises. There are constraints about localization and regional regulatory constraints. How would you design storage in such environments?
I'll start with a quick story because it's funny. I was brought in to help performance tune some queries, which is not something I normally do, but they believed it was query issues. Till I found out that the problem is the users in Asia were experiencing horrible latencies. That was because all the data was in North America and they wanted to tune their way out of that problem. I had to say, okay, here's some normal tuning thing, but here's your problem, physics. Your latency is caused by physics. If you can figure out a way to performance tune physics, you shouldn't be writing systems about invoices. You should be selling that technology for billions and billions of dollars. And they were
That's
really, at first, not happy to hear this answer that there wasn't a tool or a process or an index that could be put on things to solve what was a science problem.
Yeah, and that's a good point. And then the nuances of regulation on top of that, which make this so imperative. So, Lauris, what are your thoughts on this?
I think there was a transition that we're still in the middle of, where people thought, okay, there is no regulation. We can just have all the data from everyone globally available and everything is fine. That's not possible anymore. Getting it right and not making a mistake in a scenario like this is becoming increasingly hard for companies. So what we see is you need to keep the compute and the storage together, and the data, as you collect in one place, doesn't leave. It's almost each region being its own cloud. We can see this from AWS, where they are going all on sovereignty and they are going to completely duplicate AWS just for the European. For the people in Europe that kind of really need to stay and really need to actually follow the regulation without issue, everything will get duplicated in Europe. And we see how companies are answering this. If you look at Microsoft, they released Fabric recently. It's something that I had not seen before. Here is ISV patterns pushed even internally to enterprise. You build a platform and deploy it inside your company to different entities as a pattern recommended to handle regulation. Multi-cloud is here to stay, and you're going to keep seeing things being actually very localized and exchange across region being almost as if you were talking to two different companies.
Are you talking more about like hybrid clouds?
I'm talking Microsoft and AWS for these two things. I have not looked at Google recently, but directionally in terms of where the market is going.
Public cloud is here to stay for sure. And that's going to be one of the ways to commend this problem. Mark, any thoughts on this?
Yeah, I think more so coming from the startup area is that we do enterprise SaaS. Being a startup and doing enterprise SaaS, you do not have leverage. Our product is looking at the code itself and doing those constraints. So it's a high regulatory risk thing. The main thing that's passing security reviews is being single tenant. For one customer, we ensure it just stays in its localized area. We have global customers, some in Australia, some in Europe, some in the US. Again, they have all the different regulations and rules. Have that single tenant aspect that allows us to do that. I'm curious how we navigate that as we grow as a company and we have more leverage in our contracts to start thinking through like how the comprehensive product look like for this. But that is a future startup problem for us.
Yeah. Every startup and every large enterprise have to deal with that problem at some time and very soon.
And I think that data sovereignty is one of the big groups of metadata that we are missing out on when we do data classification. Like we do data classification now in our data models or in our designs and even post-production to say, is it sensitive? Is it PII? But we're going to have to start looking at other classification types, like what sovereignty is it allowed to be in? Like you mentioned, Europe is always the one that comes up. So Azure has had a cloud in Europe, but now they've come out with this sovereign cloud, which brings not just your data under a single sovereignty, but all your 365, your Azure Active Directory and all that stuff there. Part of the problem is that organizations don't know what the sovereignty rules are. Is it all data? Is it only personally identifiable data? Is it financial? And I'm also seeing this other trend, something we're dealing with in Canada a lot, is that it's not just where can our data be, but what places is it not allowed to be? Because that's not always outside of Europe or outside of Canada. Unfortunately, right now, the focus is not having our data anywhere in the US. But I think we're going to see more of that where it'll be either countries like China and Russia, or it will be ones where we feel that the regulatory environments aren't strong enough to protect the data, or that warrantless searches will be allowed on the data. These are really important legal problems, but ultimately they're data problems. Our attorneys don't understand data the way we do.
Excellent point. And that's a great segue into our next section, which is on data privacy and security. What are some key differences and similarities between data security and data privacy objectives and frameworks?
I'll put myself with Catherine Jarmul here. It's like you mentioned at the beginning, data security is about protecting the data from unauthorized access. It's keeping the data safe. Data privacy is about protecting the people which are represented by the data. A lot of tools are actually in common. And if you do not have data security, you can forget about privacy because basically your data is just flying around. Data security can be brought back, which is if you have one authorized access and you fix the issue, the issue is fixed. If you lose your data privacy, your data is out forever. It's a bit like permanent pollution. Another key difference in what the frameworks are trying to achieve, I don't really want to go into a list of frameworks because I think it will be boring for everyone, but you don't think about it the same way and it can be much harder to deal with privacy, which is why many companies don't typically go for this. When you talk about security, it's very binary. Either security is on or off, and your data is secure or it's not. Maybe if you have more advanced, you have a risk-based approach for this, where you say, okay, I want to protect myself against misuse, against another state attacking me, and you're going to start going for encrypting compute and secure machines. So you have a risk level, but it's fairly binary, and it's a decision for what type of environment you're in. With privacy, you make a decision on how much you want to preserve the privacy of your users. And can be something as simple as, hey, what is the privacy budget that I allow for a certain type of queries on top of data? And that's fundamentally a decision of, okay, this is what we feel comfortable with, but there is not really a magic recipe to do this. It's a decision for the company to justify in front of the legal operators and so on. Political decisions can be extremely hard to do in many sense.
Yeah. Regulation will also drive the extent of your privacy framework, right?
Completely.
I think security protects the data and then privacy protects the individual who owns the data. Any other thought?
I think one of the ways that it's significantly different is that data privacy also includes how the data is used. Many people confuse privacy with secrecy, which are two completely different things. The whole concept of recording a record of consent and then disclosing that, and then not just saying, well, the data's in our analytics system, and now we have all these tools. We can do cross-functional joins, summarize, do predictive analytics, and use AI to help sell more things. If you didn't collect that consent, you're probably not honoring data privacy. And this is one of the biggest struggles I have. A lot of privacy terms of use or other business processes might help you legally, but I also think we have an ethical obligation to make sure that we're not using data collected primarily for one purpose for another purpose without either obtaining consent or specifically disclosing it. Security is something you can manage internally, set your rules for it, test for it. But use of data is really hard to test for.
Use and misuse of data.
Yeah.
So what would be the various steps in a data privacy lifecycle? Start from discovery to determining how you're controlling your data, the process you to safeguard it. What are key steps?
Privacy by design. So it's really a set of principles on what you want to achieve. Given that when you have a privacy issue, the data is out forever and the privacy of the people is breached overall. When you try to protect an individual, it's not just the data you have. If I have this data and knowing that a lot of other data about people can have been leaked, how much can actually be revealed about a person? It's really how much data overall is available. This kind of indicates, hey, should we be collecting this at all? The default setting should be privacy. I'm European, preach for privacy by default. Privacy should not hinder functionality. If functionality requires you to invade a user's phone and steal their data, don't do it. That's not a good functionality. To go with what Karen was mentioning, it's also making things transparent, which is if you have things put in place to protect users' privacy, just say what you're doing. And if it's not good, people can tell you've done a mistake, but secrecy is not an option as long as privacy is done. So when you have a set of principles and everyone is agreed on how they are, usually you go for data protection impact assessment, the infamous DPIA. And then you explore why, you identify the need, why you're all doing this. You consult, you decide on the proportionality. You have data governance council very often that goes and do this thing. And you will see like, we're not super agile here. We actually start thinking about it a bit before because it is really hard to go back. If you do a mistake, it's a mistake that is here forever, which is why as soon as privacy is involved, you want actually this time to spend at the beginning thinking, hey, is this a good idea? It's not time which is lost. It's actually very precious time. You identify the risk and type of security measures you can think about. Now that you know where you're going and what you've done, one thing that is also in the preparation is to have an idea of data mapping. What data do we have? Why do we have it? And try to have a place where all of this is stored and constantly updated. When you start collecting the data, you need to make sure you have the legal points correctly put for you to be able to collect it. You have the effective content and you minimize the data that you collect. So the data that is collected is actually what you think you're collecting, not more, not less, just exactly what you need. When you
Mhm.
process the data, it's making sure the purpose limitations are there. So that does require you to know where the data is collected, where it's processed, and where it continues to go, which is where all the data governance tool we have around lineage and so on help tremendously achieving the outcome. And if you have third party, you have a lot of responsibility to check that the third party is actually doing what they are doing. It can be done contractually. Maybe you can run audits or third party audits for them. Storage, main thing that comes with storage is making sure you're able to handle a retention policy, enforce it, and handle a subject access request. So people need to be able to access a request and remove also the role. And that's going to be a situation that you will be in for a very long time with your product. The final step is death, because data also dies and you don't need data forever. And when you retire, it's how you dispose of the data. If you have medical data, for example, secret level, some data needs special handling to be removed. You cannot just delete it. It has security concerns as well that need to go into these. That would be like everything for the life cycle of the data and how privacy plays into it.
Oh, that was a very comprehensive and fantastic way of explaining this. So thank you so much. Any final thoughts on all of these topics? Mark, how would you like to summarize today's discussion?
Yeah, actually, the last conversation around the privacy versus security, I realized I had a fish and water experience because I come from healthcare. My training's been in healthcare where they drill into you. If you have data come out, you will go to jail. Having the whole culture, not only at the company level, but at the industry and professional level, I took that for granted because when I moved out of healthcare, not everyone thinks like that. And so I just really appreciate that kind of nuanced discussion. And it highlighted a gap for me to actually start thinking about it because I just assumed so much of it was like that because I come from healthcare. So that's the main takeaway here for me. The thing I keep hearing about privacy and security and how the rules are changing. The rules of operation are changing. The rules themselves have not changed. And so that's the main takeaway I have.
Very nice. Karen, how about you?
Okay. One of the things I say in my talks is everyone knows that ROI stands return on investment. And so much of our project description, goals, outcomes, our rewards, how we're measured is based on that. But I want to also remind people that ROI stands for risk of incarceration, what Mark said, because what we found is the penalties for breaching privacy, security, or data governance regulations have been so small that many companies are just treating it as the cost of business. And I think we will start seeing an increased level of penalties. I personally support criminal charges for organizations and people who have egregiously ignored all these things. The penalties are never going to get high enough for some companies and some cultures of companies to even put any thought to it at all.
Yes, that's a great point. I think regulations and heavier penalties are the way to bring these companies back into conformance. Lauris, final thoughts from you?
Given that people talk about privacy, I will talk about something else. We just want to bring us back to the conversation we had about the role for the data teams, the data governance teams, and the fact that AI impacts how we're going to work. It creates an opportunity to close the loop that was never present before, because now everyone works with an assistant. This assistant can pull data from anywhere and contextually relate it to what people are doing, which means that we have a unique opportunity to plug in the data catalog, data modeling rules, the EDM that we were mentioning before, directly into the hand of the people at the beginning of the chain to help them. I think it's very experimental at the moment, but I'm very excited about this because it gives us a unique opportunity to solve problems at the source.
Great. This was amazing. A big thank you to our panel. We're all leaving this roundtable a little wiser, a little better informed in this wide world of data that we live in. Thanks once again, and thank you to the audience as well.